Welcome, everyone. I am Mark Moravitz with Viasat Space for Good. You might know me already. Thank you for being here. A lot of the content that you have been able to potentially take in for Viasat Space for Good has been technical. We're talking about really, really technical concepts. But we also know that in Viasat Space for Good to be successful, our students to progress to phase two and phase three need to have a decent understanding of marketing and selling things and how do we talk about complicated concepts to people who might not be technical like me. How do we sell things, et cetera, et cetera. And we have an expert here in Melanie Gasperi, who is our global head of enterprise marketing, and she's going to tell you what that means. So we're going to dig in today on the marketing side of highly complex technical products, specifically as they relate to direct to device and Internet of Things, which is a massive area. I imagine many of you will focus part or all of your Viasat Space for Good concept on direct to device or Internet of Things in some capacity. So, Melanie, welcome. Thank you for being here with us. Tell
Thank
us,
you for having me.
we're so happy you're here. What do you do at Viasat? And what is something that, how do you know you're being successful in your job?
So what do I do? So I'm the head of marketing for the enterprise business units. Enterprise focus on all the remote sectors, commercial. So I work in sector like agriculture, mining, oil and gas, etc.
Okay.
Um, how do I know I'm successful in my job? That's a great question. So basically, it's all about engaging with our audiences and making sure that they know about us, they know about our services, they know about our capability, what we can do in the different sector we play in, and to make sure we are being known, and more recently being known in direct to device words as well. So we want to be seen and visible, and so we play a part in that.
Okay. And a lot of our students joining us, some of them are technical, studying engineering. Some of them maybe like me are studying public policy or law and are interested in the space sector. I know that you have a little bit of a non-traditional educational background as it relates to what you do today. Same for me. Tell us about your background.
Okay, so yeah, very not traditional, but so I studied in France, so I'm French. Studied in France, and after my equivalent of the A level, so I did study medicine. So nothing to do with what I'm currently doing. But so eventually move from that, and then I pursue another career. So I went then to do a short marketing course, like a 2 years course, and then after that I went to university again, and I did like law and economics, and eventually after having like a bachelor degree, I decided to move to the UK, and then, yeah, step by step, move from one company to another. So I didn't start at all in marketing and events in my career early days, but I was working in like personal assistant type of role, and then events management, and then eventually I moved to marketing, and then
Wow.
yeah, made
Okay.
my way there.
So economist, doctor, lawyer, marketer, you do it all. Incredible.
Yeah, basically.
Well, let's talk more about that when we have more time. So we have 11 key areas that our students can choose one or more that their concept is focused on. Direct to device and Internet of Things is one of those. And I said a minute ago, we anticipate that being a popular choice because there are so many real world applications in terms of how that type of technology can improve life on Earth, which is a focus of Space for Good. So can you give us a little bit, particularly for people who are non-technical, how are we defining what is direct to device, we say D2D, and what is Internet of Things, IoT, as it relates to space technology?
Okay, so I'm not technical either. So and part of my role is actually to simplify some of the concepts so it can be understood from a broader audience. But so direct to device, so basically allows everyday devices to connect directly to satellites without the need for like a specialized satellite terminal. So this is very high level. And so basically those devices can switch from satellite connectivity when cellular coverage is unavailable, sorry, or we are in a congested area. And you don't need to do anything. Basically, the switch does it automatically. And basically, the purpose of direct to device is to fill those critical gaps when traditional network falls short, and enable to ensure that people and devices stay connected even in the most remote or challenging environments. Yeah, and IoT, so Internet of Things, is basically devices which connect things between themselves or directly to the satellite as well. So it will be a similar context, but with those devices.
Okay, got it. That's fascinating. I mean, I'm already thinking of, I'm sure, in disaster preparedness and
Mm.
response, this is huge. I'm sure with climate change and the things that are happening with that around the world, this is extremely important technology, et cetera. So I'm excited to dig in.
Mm.
Okay, so direct to device right now, you said like a normal device not requiring a huge antenna. What are the most substantial technical limitations right now to the technology? And you said a minute ago, you take complex ideas and distill them in a way that someone like me can understand. So I'm excited to hear the limitations in a way that anyone who's not technical can understand.
So in terms of the limitation, so I think we're still early in the implementation of D2D. So it means that although we have the technology, so the technology is still evolving, but we also need to make sure that the ecosystem also are ready to embrace this technology. And so one of the limitations, for example, is that not if I take one of the applications, so smartphone, so you can have your smartphone directly connecting to the satellite. Not all smartphone, for example, or not all IoT devices are enabled yet to connect to the satellite. So D2D works best when you have like newer hardware, for example. So that will be one limitation. The D2D is also available today on narrowband, which means that you have certain limitation in the application currently. So it's optimized for like shorter messages, SOS, text, SOS text or voice calls, but you cannot do streaming or video, etc. So that would be another limitation.
Okay.
Um, and without going too much into detail, but other limitation, for example, so you probably heard about spectrum. So basically, we use specific radio signal to communicate. So the spectrum and spectrum are limited in space, and they are already basically using a lot of service are using spectrum. So you always need to make sure that you optimize the spectrum you're using. And also you need to think that government regulates spectrum nationally to avoid interferences or protect the public services. So basically D2D use spectrum shared with existing mobile and satellite systems. So yeah.
So the way I understand it is it's a physical pipe. So much can fit into that pipe, and you have to manage your piece of that flow really, really well because you
Yeah,
don't get any more. Is that
exactly.
okay?
And because it's
Um,
limited, you need to make sure it's very optimized so you don't lose, some very important resource, basically.
okay. I imagine that there are so many applications of space-based IoT that the average person like me simply does not know about. I would love it, Melanie, if you could tell us a use case for IoT that most people probably don't realize.
Yeah, so we have a few, so especially in enterprise, so it's basically our specialty in terms of we have a lot of space-based IoTs that support environmental protection, resource management, public safety. Like for example, we are working with partners to monitor forest wildfires. So enable to detect early if there is any smoke or fires and basically send help before it goes is too late basically. Other very interesting use cases we are doing is we work with large farms in the US or in Australia, and you have to think those large farms, their operation is in very remote terrain. They have cattle with water tanks, and you can't always send people every day because it has a huge cost. Sometimes you have to go by helicopter to the place, and so that represents huge cost, but also that can also be some issue for the person going there. It could be there could be some safety issue for that person. So what we do is we are able to monitor those water tanks remotely to make sure everything works fine, that the water is there, that the pumps works, etc. So it enable like a huge cost saver, but also enable more safety for the worker. And another one which I find really, really cool and close to my heart is also we are able to do some wildlife tracking to monitor endangered species. So, for example, we can monitor gorilla populations in Uganda, or we can also monitor elephants to avoid them to be poached, for example, or at least be able to do something about it if we see that there are some traffic being done.
Wow.
Mm.
A couple of these I didn't know about. I'm incredibly inspired. Monitoring forest, making sure that cattle have their water and their food, endangered species being supported to grow their population, all incredible uses. And I just want to ask a question. So, presumably, the reason satellite technology is extremely important here is because all of these little sensors that make up an IoT network, they're potentially thousands of kilometers away from terrestrial signal, from a cell phone tower or something like that, correct?
Yeah,
Okay.
exactly.
Okay. Wonderful.
Mm.
That's incredible. Okay, let's move on to we kind of talked about congestion already a little bit with the pipe example. We know there's warfare, there's hackers, there's all of these types of things. How do um, companies and countries protect their D2D and IoT infrastructure from jamming, from cyber attacks, those kind of things, and how do we at Viasat specifically approach that?
So basically, the goal here is to ensure critical connectivity can adapt, recover, and continue, even when conditions are unpredictable. So the system are designed so they don't depend on a single satellite signal or pathway. So if something disrupted, communication can reroute or recover. Another thing around protection, so protection against cyber threats and interference, sorry. So this is designed into the network from the start. So it's not something that we layer later. So this is from scratch, we really think about those things. We also use like a mix of space-based and ground-based assets. We also can use multiple orbits or networks to help reduce the single points of failure, for example. And also something, so we track objects. We're trying to like make sure we avoid collision of satellite or we're managing as well the satellite life cycle. So to reduce risk from debris or congestion in space. And that is even more important when there are tense environments. And at Viasat, so we have a NOC team, so it's our network operations center. So they work 24 hours, 7. And this is what they do. They manage our satellite, make sure that they are moving them whenever needed to make sure they are still covering the right zone, but also don't collide with other satellites. But I mean, our satellites are in a geostationary space, so there are quite a lot of space, but still, it's important that we have a team to monitor and manage that.
Okay. And I have been to the knock, and it's incredible to see the level of
Mm.
detail that our pilots and operators can see to keep our systems safe, to have our redundancies in place, et cetera. Okay, so we end every interview, Melanie, asking the expert we're speaking with you to give
Mm.
our Viasat Space for Good students advice. And I think this one is particularly interesting, given that a lot of our students probably won't be taking marketing communications courses at their schools. So, what advice do you have for our Viasat Space for Good students as it relates to taking a complicated idea and selling it, or distilling it in the way that someone in a government can understand who's not technical, so they can be successful in our program?
So I think the something I learned throughout all my career is the very important thing is to put yourself in the shoes of your audience. And so, I mean, first of all, you need to understand the concept of what you're talking about. So it's important to understand the high level at least. So I'm not technical, as I said, but I'm curious and I like to understand things. So sometimes going in the depths of things, and then after you're trying to see it in the shoes of your audience. So if you talk to a salesperson, if you talk to someone from a government or someone technical, obviously you will have a different way of saying things. And then yeah, I think those are
Okay.
the thing I apply usually.
So essentially, pretend you are your audience and make sure that that person, the characteristics of them, that the way you're explaining it makes sense to them. I love that. Okay,
Mhm.
great advice. Well, Melanie, thank you for your time and your expertise. I know that our Bias Space for Good students who take in this content will learn a lot from this conversation. We'll see you soon. We'll definitely see you at Space for Good UK finals, if not more.
Mhm.
And we'll talk soon. Thank you. Bye, everyone.
Thank you very much. Bye bye.